Jakarta, which is the capital and also the largest city in Indonesia, is home to about 11 million people. 13 rivers intersect Jakarta, and every year floods occur in this city due to large rainfall. Over the past few years, Jakarta has seen a rapid urbanization and thus a rapid increase in its population. This has resulted in an increase in the number of informal settlements around the city. Due to poor rainwater catchment services and rapidly decreasing groundwater reserves, many of these informal settlements do not have sufficient access to clean water. These images were taken in an informal settlement in Kamal Muara, located in Jakarta. This village has adapted to the heavy rainfall and poor infrastructure by implementing a homemade system to collect rainwater in rain barrels using gutters, funnels, and pipes, earning itself the name the Rain Catcher Village. The usage of rain barrels, gutters, and other water catchment systems are already widely used in the rain catcher village, showing that these systems are already accessible and able to be utilized in other informal settlements in Jakarta. However, many of these systems require vast community engagement to be properly effective. Furthermore, they are not perfect and the water could still hold many contaminants and will need to be further treated.
One of the biggest issues of this system is that prior to rainfall, the roof or the gutter is exposed to the elements. This means that there are leaves, animal fecal matter, and other hazardous particles that would get washed off the roof and directed into the rain barrel. This sediment can not only make the water less pleasant to drink, but can also promote algal growth. First flush diversion is a common technique in more advanced rain harvesting systems. This is where early rainfall is redirected outside of the rain barrel. First flush diversion is effective since most undesired particles are washed off the roof in these early stages of rainfall. But the problem with this is that implementing first flush diversion requires the purchasing of somewhat expensive components which are difficult to install. As such, these systems that already exist in the market are unable to be utilized effectively by those living in Jakarta's informal settlements. This is where we can help. Our proposed first flush diverter builds upon the idea of current first flush diversion techniques by providing a cheap and adaptable solution that is simple to implement. All that is required is a plastic bottle of at least 1 to 2 liters and a flexible floatable ball such as a filled balloon or a thin plastic ping pong ball. The bottle must be watertight, and the ball must be able to be placed inside of the bottle while still having a larger diameter than that of the bottle's neck. This would then be fixed onto the gutter. The way this device would work is very simple. As the contaminants on the roof are swept up by the initial few millimeters of rainfall, these are diverted into our first flush system. The ball would then float to the top of the bottle until the bottle is sealed, allowing the rest of the non-contaminated rainfall to be collected by the rain barrel as usual. The system would then be cleaned and reused.
These videos show how the first flush diverter would generally work, however they are quite exaggerated due to the large amount of contaminants and high volumetric flow rate. But note how the ping pong ball seals the bottle after enough water has been diverted. The first flush diverter is adaptable and cheap and can easily be used in informal settlements with rainwater harvesting systems. The diverter avoids sediments from forming within rain barrels, which not only reduces algal growth, but also makes it easier for populations vulnerable to water insecurity to treat rainwater. By reducing sediments, common water treatments such as solar disinfection or filtration are much more effective, and this helps achieve Goal 6 of the UN Sustainable Development Goals. In Jakarta, residents in informal settlements are directly affected by poor rainwater management, which leads to poor living conditions and devastating floods, and they're also well aware of the negative impacts of excessive groundwater extraction. Community engagement in these issues is therefore high, encouraging the implementation of our solution as it reduces dependency on groundwater and prevents the formation of stagnant puddles by encouraging collecting rainwater from roofs. This helps achieve Goal 11 of the Sustainable Development Goals. By improving rainwater harvesting, our solution is in line with the Sphere standards, especially water supply, sanitation and hygiene. The Sphere standards aim to avoid the use of bottled water and also state that the total basic water needs is 7.5 to 15 litres per person per day. Considering the high rainfall in Jakarta, these standards are easily achievable with rainwater harvesting. However, even if this is not completely achievable, the standards aim to limit household income spent on water to 5%, which rainwater harvesting helps to achieve. The effectiveness of the diverter can be measured by adding a certain mass of safe sample contaminants to the roof or gutter, hosing down the roof or gutter, and then measuring the remaining mass of contaminants in runoff. This method can be used to determine whether certain improvements need to be made, such as increasing the volume of the plastic bottle. Team Cloudburst ultimately aims to improve rainwater harvesting in vulnerable communities and believe that first flush diversion can specifically help urban informal settlements with high rainfall, such as those in Jakarta.